All right, hello. I'm in the Pilot's Handbook of Aeronautical Knowledge. I'm in Chapter 4, Axes of the Aircraft, 4-11. The axes of an aircraft are three imaginary lines that pass through an aircraft's center of gravity. The axes can be considered as imaginary axles around which the aircraft turns. The three axes pass through the center of gravity at 90-degree angles to each other. The axis from nose to tail is the longitudinal axis. The axis that passes from wingtip to wingtip is the lateral axis, and the axis that passes vertically through the center of gravity is the vertical axis. Whenever an aircraft changes its flight attitude or position in flight, it rotates about one or more of these three axes. All right. The aircraft's motion about its longitudinal axis resembles the roll of a ship from side to side. In fact, the names used to describe the motion about an aircraft's three axes were originally nautical terms. They have been adapted to aeronautical terminology due to the similarity of motion of aircraft and seagoing ships. The motion about the aircraft's longitudinal axis is roll. The motion about its lateral axis is pitch. And the motion of its vertical axis is yaw. Yaw is the horizontal left and right movement of the aircraft's nose. The motion about the aircraft's longitudinal axis is roll. So if it's got a pin through it and it's rotating on or rolling on that pin, the motion about its lateral axis is pitch. So it's got a pin going left and right. And yaw is the horizontal left and right movement of the aircraft's nose. The three motions of the conventional airplane, roll, pitch, and yaw, are controlled by three control surfaces. Roll is controlled by the ailerons, pitch is controlled by the elevators, and yaw is controlled by the rudder. The use of these controls is explained in Chapter 5. Flight controls, other types of aircrafts may utilize different methods of controlling the movements about the various axes. For example, weight shift control aircraft control two axes, roll and pitch, using a frame suspended from flexible wing attached to the three-wheeled carriage. These aircraft are controlled by moving a horizontal bar called a control bar in roughly the same way hang glider pilots fly. They are termed weight shift control aircraft. Because the pilot controls the aircraft by shifting the center of gravity. For more information on weight shift control aircraft, see Federal Aviation Administration Weight Shift Control Flying Handbook. In case of the powered parachutes, aircraft control is accomplished by altering the airfoil via steering lines. A powered parachute wing is a parachute that has a cambered upper surface and a flatter undersurface. The two surfaces are separated by ribs that act as cells, which open to the airflow at the leading edge and have internal ports to allow lateral airflow. The principle at work holds that the cell pressure is greater than the outside pressure, thereby forming a wing that maintains its airfoil shape in flight. The pilot and passenger sit in tandem in front of the engine, which is located at the rear of the vehicle. The airframe is attached to the parachute via two attachment points and lines. Control is accomplished by both power and changing the airfoil via control lines. Alright, we're going to hold off there. That was just axes of the aircraft. See ya. That was axis of the aircraft 411, 412.